Okay, so we're going to be looking at linear correlation. We want to find the relationship between two variables. And we only care about linear cases where one versus the other makes a line. Now, back in college algebra, you may remember you called your variables the independent and the dependent variable. Those words mean something different in a statistics class. So we don't say independent and dependent. We use these terms. We're going to call our x variable our explanatory variable and our y our response. Now remember, correlation does not imply causation. We're not saying that we know x causes y or x explains y. We're saying that somebody gives us a data or a data set. We have to start with a guess that we think maybe one causes the other. So we're going with the assumption that maybe x might explain y. And then the next thing we do is we draw a scatter plot. It's important that our scatter plot starts at 0 because we want to be able to see our y-intercept. And then we ask ourselves, do we see an association? Is there a pattern? If we don't see a pattern, we're done. We stop. We move on. We don't know how to do anything other than linear correlation in this class. Next thing we ask is the data linear? And then we ask, are there any outliers? So here we have vacation days versus food costs. If I were to look at this data, I would say I don't see any pattern. That doesn't look like a line to me. We're done. We stop. We move on to the next problem. Here we're looking at this is from your book, this picture. Excuse me. Well, we did a taste test on cookies. Somebody baked cookies at a whole bunch of different temperatures. Judges scored them based on it looks like a scale 1 to 10, 0 to 10. And these are how the cookies came out. So do we see a pattern? Yeah, I see a pretty clear pattern. Does that pattern look linear? Does that look like a line? No, that looks like a parabola to me. We'd stop. We can't do anything with this data. There are things you could do. We could do what's called quadratic regression, but we don't learn that in this class. By the way, look here. What temperature gave you the best cookies? Looked to be right around 350, 375, which is exactly what Pillsbury tells you to bake your cookies at. Then we got to watch out for outliers. This graph, also from your book, tries to relate shoe size to IQ. Do you think there's any relationship between shoe size and IQ? Of course not. But if you plug all this data into your calculator will give you a moderate correlation. And the reason is this data point right there. That's Bozo the Clown. He was a real person. Bozo the Clown's a real guy. He happened to be a genius. He also happened to have giant feet. And if you include that outlier that clearly doesn't fit with the rest of the data in your data set, then your calculator will suggest there's a relationship that isn't really there. So our first step is draw our scatter plot and put our explanatory variable here, what we think might explain our response variable. Look at our graph and say, do we have some kind of linear graph? Does it look like a line? And are there any clear outliers? Then we can describe how strong we think that relationship is. So our calculator will give us this number. It's called the correlation coefficient. And it's a measure of how strong that relationship is. It's always between -1 and 1. Correlation coefficient, always between -1 and 1. Now I made up these boundary values here. These are not strict, but they're pretty good guidelines. A strong correlation is close to 1. A weak correlation is close to 0. Strong's close to 1 or -1. Weak is close to 0. So strong positive would be positive numbers close to 1. Weak positive would be positive numbers close to 0. And in between there, like around a half, we would call moderate. And then the same for negatives. Close to -1 would be strong negative. Negative but close to 0, we would say weak negative. And then around -0.5, we would say moderate negative. So here are some pictures of these. Strong positive, see how these are all pretty close to a line. They're all tight against a line. This is even stronger because the data points all fall pretty much along a line. This is going down, so that's negative. That's going up, so it's positive. Moderate would go up, but be a little more spread out. Weak would still kind of go up, but be very spread out. And then negatives go down. So here's negative strong, negative moderate, a little more spread out, negative weak. And then no correlation would just be completely random spread out.